All right, so welcome back to environmental economics. Um, just so everyone is on the same page, the plan for today is really to go over some of the present value math in our cost benefit analysis unit. So we had a video posted before class talking about how we do these cost benefit analyses. We're going to run through some math examples today. With Monday, the video posted before Monday, we'll go over how we do valuation. Monday, we'll close that chapter out. And then a week from today, Wednesday, you guys will start brainstorming your paper topics. And the things to keep in mind here are you should post your paper topic ideas to the discussion board before that class period. And not this Friday, but next Friday, after you've brainstormed ideas with your classmates, I want you to submit a paper proposal to me. So your paper topic needs to be approved by me before you move forward on it. Any questions? Okay, so what we're going to do now is just go over some examples from chapter 5. And if you have a question, just shout it out. I can't see you, and I can't see the chat box right now. So just shout it out and let me know if you've got anything. So examples from chapter 5, and sort of to bring it full circle, what we're dealing with these examples is that Econ has a problem with intertemporal decisions, right? So here in environmental economics, we are going to be comparing costs and benefits that occur at different points in time. And oftentimes what we'll see is we pay our costs up front for benefits that we're not going to see materialize for some time. So you might think of comparing the costs for abating carbon emissions today with benefits that future generations are going to see, and we need a way to compare those costs and benefits. Or more simply, would you all prefer $900 today to $1,000 2 years from now? And really, we're going to start with this second example because it's much more instructive as to the way we approach this problem. And the way we approach it is with this solution concept of discounting. So we talked about it a little in the last video, but just to make sure everyone's on the same page, discounting describes the valuation in present day terms of future outcomes. And those outcomes can be damages, they can be costs, they can be benefits. Relevant to what we discuss in 201, they can be our utility values. And the way we describe these valuations in the future in present terms is with a discount factor. A discount factor gives the value of one unit in the future in 1 year. So you can think of this one unit as $1, one utile if we're talking about utility values, one unit of something in 1 year. And to get that discount factor, we need a discount rate, the rate at which the future is discounted. So we've got a little formula here, D equals 1 over the quantity 1 plus R. Questions so far? So from this discount factor, this D equals 1 over 1 plus R, we should start seeing some concepts we're already familiar with, present value and future value. And of course, I've got the formulas for those right here. Present value for x in t years is x sub t over 1 plus r, this quantity raised to the t, where t is a period. So t is number of years, r is the periodic rate. We've also got future value on this side, x sub naught, so our initial value, multiplied by this quantity, 1 plus the periodic rate, raised to the number of periods. So we see that discount factor up here looks a lot like present value down here. In fact, we can note that discount factor equals present value where our future value is 1 and our number of time periods is 1. So if x sub t equals 1 and t equals 1, then present value equals d, the discount factor. Questions so far? All right. So what does this look like in practice? Well, we can have any number of discount rates. Higher discount rates mean that we value the present more. Lower discount rates mean that we value the present less. But for the purposes of computing it, we might use interest, yearly interest, as our discount rate. So as an example, if I have a $1,000 bill to pay 1 year from now, what is that bill? What is that future obligation worth today? And for this example, I've posited an interest rate of 5%, but we can consider other interest rates in the future. But with an interest rate of 5%, I can deposit $952 today, and a year from today, including the interest I earn on it, it's going to be worth that $1,000. So the present value of $1,000 in 1 year is 1,000 times that discount factor. Remember, d equals 1 over 1 plus r. It's $1,000 times that discount factor, which is 1,000 over 1 plus the interest rate, $952. Questions so far? We started this example by saying, would you rather have $1,000 in 2 years or $900 today? So let's see what it looks like in a 2-year circumstance. What if I have to pay a $1,000 bill in 2 years? What is it worth today? Well, we've got that same interest rate. We're assuming that interest rate doesn't change. We're not assuming inflation or anything complex. But if I deposit $907 today, in 1 year, it'll be that $952 we saw in the last slide. And if I reinvest that $952, it'll be worth $1,000 in year 3, or year 2 starting at year 0. So $952 times this quantity 1 plus the interest rate is the same thing as $907 times this quantity 1 plus the interest rate squared. $907 times 1 plus the interest rate squared is $1,000. $1,000 in 2 years with a 5% interest rate is worth $907 today. Should say 907, not 952. I just forgot to. So the present value of $1,000 in 2 years is 1,000 times the discount factor squared, 1,000 over 1 plus r raised to the power 2. That's $907. We started this with a motivating question. Would you rather have $1,000 in 2 years or $900 today? Well, if the interest rate is 5%, and if we're assuming that the discount rate and the interest rate are the same thing, then we would rather have $1,000 in 2 years than $900 today, because $900 today has a present value of $900, and 1,000 in 2 years with this interest rate has a present value of $907. And we can use this reasoning to think about other sorts of benefits which we might experience in the future, perhaps benefits from carbon reduction. Questions so far? So we've got a good mode of discounting, but we want to take that mode and apply it to cost benefit analysis. In general, in environmental economics, what we want to do is evaluate a project or cash flows that give rise to benefits in some periods and costs in other periods. And again, for the most part, we're going to be looking at costs upfront payments, and benefits that accrue over time. So our solution concept here is cost-benefit analysis. And what we have to do in a cost-benefit analysis is assess all the costs and all the benefits in different periods in dollar terms. Not only in dollar terms, but typically in present terms. And a project passes cost-benefit analysis only if in present value terms, the benefits exceed costs. We have a tool we use to assess whether the present benefits exceed the present costs, and that's net present value, which is the sum going from now to some period t in the future of benefits minus costs, so net benefits discounted to the present. So the sum net present value is the sum of present values of net benefits. And a project passes our net present value test if the sum of all these present values is greater than 0. Questions so far?
What would you use that equation to solve necessarily?
So great question. Let's look at this example, which you guys will be doing on your own. Suppose we're comparing two projects and we want to know which, if any, to invest in. Right? And so the example I gave was something with carbon abatement, but it can be anything. It doesn't have to be environmental. But Christina, you're interested in cleanup of Flint, Michigan. That's going to be costly, and it's going to entail a large upfront cost. It will certainly accrue benefits in the future. How do we know whether those large upfront costs are worth those future benefits? We do a cost-benefit analysis with net present value. So Annika, does that answer your question?
Yes, it does.
Great. So let's, on our own, and we'll regroup in the class as a class in a few minutes. Let's calculate net present value for both these projects, Project A and Project B, and let's assume a discount rate of 5%. And for everyone's benefit, I put that net present value formula up there. And if anyone needs any help interpreting the formula, you can just message me in the chat. And so by now you should have the net present value for Project A. Let's take a few minutes to wrap it up and calculate it for Project B. All right, how are you guys doing so far? Do you have an answer, or alternatively, are you completely lost?
I just need more time to finish calculating.
Okay. Anyone else?
I think I did it right, but I'm a little unsure. But yeah.
So one thing you'll note while you guys are doing these calculations is these projects have the same upfront cost, that cost of $30 in year zero at our initial point. But they accrue different benefits in each of the following years. So while you guys are finishing calculations, one thing that should be clear before we plug anything in is because they have the same cost, but Project A just has so many more benefits. Project A probably has a higher net present value than Project B. All right, how are you guys doing on calculations? Everyone good? All right, so who wants to walk us through how they solved this problem? Christina, you said you think you get it, but you weren't sure if you were approaching it correctly. Are you comfortable sharing with the class what you did? Let's start with Project A.
Sure.
Okay.
Actually, I don't know. I mean, I guess I'll just say what I did, but
Okay.
So like you said, we have a cost at the beginning in year zero of -30, and then benefits after that, basically. So
right. So we start with -30, and you'll note that because this is year zero, if we plugged it in, so there's no benefit in year zero, benefit is 0. The cost is 30, so -30. So 0 minus 30 is -30. We can calculate the 1 plus r, 1.05, but when we raise it to that power, anything raised to the 0 power is 1. So the net present value, if all we were considering was year 0, would be -30. So what do we get for the present value for year 1?
Oh, we're supposed to do all this individually.
Well, I don't know what you mean by individually, but what net present value is the sum of a bunch of present values.
Yes. So you wouldn't like subtract that cost from the other 3 and then make it year 3?
No, because as we can see from this table, we pay $30 in year 0. We get a benefit for Project A of $20 in year 1. A year passes, we get another benefit of $20 in year 2. Another year passes in this 3-year project, we get another benefit of $20 in year 3. But remember, we have to discount them because there's a time value of money, because we have time preferences over money. And so $30 now is different than $20 or $30 or whatever a year from now, 2 years from now, 3 years from now. So the whole thing we're doing here is seeing whether it's worth it to get a future stream of $20 a year for 3 years, given that we have to pay $30 up front. So let's go back to this Project A. We started calculating the net present value of project A. We know we're paying $30 up front. What's the present value of $20 a year from now? Anyone know? And you don't have to say the number, you can just tell me the formula.
For the second year of Project A?
Mm-hmm.
Is it -19?
Well, it should be positive because we're getting a benefit of 20. But let's calculate it out. Because what we have here is what is the present value of $20 a year from now? And we've got a formula for that. It's 20 over 1 plus the interest rate. In this case, we have an interest rate of 5%, so 1.05 raised to the power of 1. Any questions on how we got that? So the present value of $20 a year from now at this interest rate is going to be like $19.04, give or take. And as always, apologies for my e-pen handwriting, but can everyone see that okay? So let's keep it going. How do we get the present value of the benefit to Project A 2 years from now? Same thing, we take the net benefit. So we benefit 20, we have no costs in year 2, so it's just that net benefit 20 over this quantity 1 plus the interest rate, so 1.05, raised to the number of periods, in this case 2. And same thing for year 3. That's a 1.05 cubed. Questions so far? Does everyone see how we did that? So let's fast forward. The net present value for Project A is just the sum of all these present values. We have an upfront cost in year 0 and a bunch of present values. We get a net present value of $24.46. And that includes this upfront cost of $30. When we do the same thing for Project B, we see it's much smaller. In fact, in this case, it's negative. And that's because we pay $30 up front, we accrue $30 worth of benefits over time, but because there's time value of money, we have to discount each of these $10. So we know it's going to be less than $30 of net benefit with a $30 cost. Put differently, in doing this cost-benefit analysis, only Project A is worth the undertaking of a $30 upfront cost. Questions so far? So what if the costs and benefits get a little jumbled up? So here we have 2 new projects, Project A and Project B, both with a discount rate of 5%, but this time they've got a little different benefit stream than last time. Take a minute on your own to calculate the net present values for Project A and Project B, and we'll regroup in a second. And if anyone has any questions, just shout them out or drop them in the chat. So by now you should have project A wrapped up and be calculating the net present value for project B. Okay, so who wants to walk us through how they calculated these new net present values for project A and project B?
I can try.
Okay.
So of course you have negative 30.
Okay, so
Negative 30 plus plus 20 divided by 1 plus our discount rate of 0.05, which equals 19.04. At least that's what I got. Then 10 divided by plus 10 divided by 1 plus 0.5, 0.05 to the second power.
Yep.
Right? And I got 907. Then you do plus 10 divided by 1 plus 0.05 to the third power, and I got 8.63. And as a total, I got 3674.
Okay. So I think you got your calculations a little wrong, but you got the problem set up quite right, which is, just summing up all our present values.
Oh, I forgot to subtract the 30.
Yeah, and the rest just seemed like round off error. But I got 676 for project A and 1494 for project B. What about you guys? Did you get the same thing?
Yeah, that's what I got.
So which of these projects passes cost-benefit analysis?
What do you base that off of?
So passing cost-benefit analysis means if the sum of net present value, if net present value is greater than 0.
Okay, so then yeah.
So which of these projects pass cost-benefit analysis?
They both would because they're greater than 0?
Great job, they both would. What if we only had $30? What if we could only invest in one project? Which project would you invest in?
Would it be the B?
Yeah, it'd be the one with the higher net present value. It has a greater stream of discounted benefits. Questions so far? All right. So what we're going to do now is just wrap up class with a little bit of practice problem. But when I say practice, I really mean practical. So, and Annika, this I think also addresses one of your earlier questions, which is how do we use, like what do the projects we use NPV for look like? So imagine we can revamp our Sweetbriar campus heating system in such a way that dramatically reduces emissions. Such a project would cost $20 million right now. But because we're reducing emissions, it's going to save us $1.5 million a year for 15 years. Starting next year, we can call that year one. We'll pay $20 million right now in year 0. So assuming no inflation and that these are all real numbers, or real terms, I should say, can you come up with a discount rate which passes our cost benefit test and one which does not? So in case it isn't clear, I really mean to be exploratory here. I'm not asking you to solve it using logarithms or anything. What I want you guys to do is open up a spreadsheet and play around with some numbers and tell me what discount rates pass cost benefit, which do not. And remember, higher discount rates mean we value the future more. Sorry, higher discount rates mean we value the present more. My apologies. So take a minute, open up Excel or whatever spreadsheet program you have on your own computer, and play around to find these two discount rates. One which passes and one which does not pass. Does not. Questions so far? Is it clear to all of you what we're doing with this practice? Okay, so let me know if you have any questions. You can either ask out loud or drop it in the chat. But what we have here is a project with an upfront cost and a flow of benefits. We want to know under what circumstances this project is worth it and under what circumstances this project is not worth it. And again, you guys should be exploratory here. You should use a spreadsheet program. You should play around with it. And then we can see your numbers together. So even if you haven't found a discount rate, has everyone set up the problem yet? Or alternatively, does anyone need help setting up the problem? You can shout it out or you can drop it in the chat. And has anyone found a discount rate yet for which this, oh, I can clear up this screen, for which this both passes and doesn't pass? Has anyone found a discount rate yet? So if you've set up the problem and you've plugged in a rate, either that rate should pass or not, right? So you've done at least half the problem. And we know that lower discount rates mean that we value the future more relative to higher discount rates, meaning we value the future less. So if you have one rate and you know whether it passes or doesn't, think about what the second rate should look like. All right, so first, I've got this set up. I've got 15 years. We've got an upfront cost and an annual benefit. Can everyone see my screen okay? So what's our upfront cost?
20 million.
20 million, and what's our annual benefit?
1.5 million.
All right. So we can plug that in. $20 million and $1.5 million. And we saw earlier, what we want is to list all the years that will be accruing these benefits of $1.5 million a year, and then discount them. So did anyone come up with a rate that passes muster, that passes our cost benefit analysis? No one came up with a rate? Does anyone want to see how we do it?
Yes, please.
All right. So the rate I came up with that passes is 1%. You can come up with other rates that pass, but the rate I came up with is 1%. So we've got this upfront cost and this annual benefit. What we want to do is discount this annual benefit for each of the years of the program. So you can see here, in this first cell, I have our annual benefit discounted at a rate of 1% by the year of the benefit, in this case, year 1. Down here, I have our annual benefit. For those of you who aren't comfortable with Excel or spreadsheet programs, these dollar signs just mean it's a stable reference, so it's always going to be whatever I put in this cell. Discounted by our rate, 1.1%, for the 15th year of the benefit. when I add up all these accruing benefits, I get 20,800,000. And when I subtract the 20 million, that upfront cost from all these benefits, I get a cost benefit analysis of about $800,000. Questions so far? So what's a rate that might not pass cost benefit analysis? If I'm looking for a rate that will not pass cost benefit analysis, is it going to be higher or lower than this rate? What do you guys think? Well, what would it look? Someone give me a number that's lower. What's lower than 1%? This is not a trick question. Give me a number that.
0.5.
Okay. And what's a number that's higher than 1%? So let's see if a number that's lower also passes cost benefit. All I've done is use that same formula, but change our discount rate. And already it looks like with a lower rate, our present values are higher. Here we have 1.48, here we have 1.49. And summing those up, whereas previously we had 20,800,000, here we have 21,600,000. So it looks like lower interest rates are going to pass cost benefit analysis. So what might not pass? You guys with me so far? Questions? So if 1% and lower passes, give me a number that might not pass. Just shout one out. All right, well, I came up with 3%. 3% does not pass cost benefit. We discount it the same way. And we see is the net benefits are about 1.8 million. But the upfront, or sorry, I should say 18 million. But the upfront cost is 20 million. So 18 million of benefits for the next 15 years does not beat out the upfront cost of 20 million. Questions so far?
Can you say the formula you did again real quick? Sorry, I missed it.
Rather than me say it again, why don't you tell me, what is our formula for net present value? Because I didn't use anything in that slide that we haven't already learned.
Like I get, it's your, what's that called? Not reoccurring a payment. What's it called? Cash flow.
Okay.
Isn't it cash flow divided by 1 plus your rate? But I don't know how the initial fits in there as well.
Right. So so don't think in terms of cash flow. We're not accountants here, we're economists, which means we can have benefits outside of cash. Certainly it's our job to put a dollar value on those benefits, but clean air is a benefit, and happiness and friendship are benefits. And if we can equate a dollar value to that, that goes in our net present value calculation. But you're right, it's some future benefit discounted by the rate, so 1 plus r, raised to the number of periods with which you are discounting.
Mm-hmm. Okay.
So we see that right here, sum of benefits minus cost discounted. So what we just did was we came up with a rate that doesn't pass cost benefit analysis. That was 3%. And we came up with a rate that does pass cost benefit analysis. That was 1%. Note that with higher rates, it means we value the present more. So accruing benefits in the future is not worth as much because we value the present more. Questions so far? All right. So we came up with a discount rate for which this policy, revamping the heating system, passed and didn't pass cost benefit. But what if there are more costs than just the $20 million to revamp our heating system? What if there are social costs? How big would the social benefit of the emissions reduction need to be in order to make this project pass if it considers social costs? And for this one, let's assume that 3% rate. So to be clear, when I say it costs us 20 million, that 20 million is now inclusive of social costs. So does anyone need help setting up this problem, or does anyone have any questions about what it is we're answering right now? So the good thing is we've already set up this problem based on what we did in the last one. So give me a second to reshare the screen. But we have an upfront cost of $20 million. This now includes social cost. We have an annual benefit, not including social benefit, of $1.5 million and a 3% rate. So we discount that benefit, we run our cost benefit analysis, and we see that previously we fell short about $2 million. Which means if we had an additional discounted $2 million of social benefits, $2,093,097 to be exact, it would then pass. Because remember, to pass cost benefit analysis, we need in this case CBA, but our net present values to be greater than 0. Questions so far? All right, well, that's all I've got for today. I'm gonna stop sharing the screen. I'm gonna open it up for questions, and you guys can tell me what you've got. All right, if there are no further questions, we'll regroup on Monday to finish our cost-benefit analysis chapter. Have a good one, everyone.
Thank you.
Bye-bye.
Thank you.